Hello, so we'll be looking at a few probability and counting principle questions from Algebra 2 and then trigonometry. So first, here, determine the number of possible outcomes. Tossing a die 3 times. Now, how many possibilities do we have? First die have 6 possibilities because a die has number 1 through 6. Second die also has 6 and third die also has 6. So therefore, we'll end up getting 6 times 6 times 6, which is 216 possible outcomes we could have. Alright, now, number 20, choosing a breakfast of juice, cereal, and fruit from 3 juices and then 5 cereals and 4 fruit. Because you have to pick one of each, what we have to do is we have to pick 1 out of 3, which is 3 choices, 1 out of 5, which is another 5 choices, and then 1 out of 4, which is 4 choices. And therefore, when you multiply over 3, we'll end up getting 60. So 60 choices will be our all possible outcomes. Sitting and A, B, C, D, E in a row. Let's think about it. If we have 5 people sitting, how many possible candidates can we have on the first sitting? It's going to be any one of those 5. Second, it's got to be 4 because one person was already sitting on the first seat. How about this one? Yes, we only have 3 people left because 2 people are sitting on the other 2. And then here we have 2 people sitting, and whoever didn't get to sit on the last spot has to sit over here by default. So when you multiply 1 through 5 altogether, we'll end up getting 120. So there are 120 ways in this case. Alright, let us try to evaluate this expression. This is called 5 factorial. That means 5 times 4 times 3 times 2 times 1. Whatever that number is, we have to multiply all the way down to 1. That's equal to 5 factorial, which is equal to 120. Now, I'd like to show you how we can do this one using the calculator. So here we have, we can press 5, and let's go for math, and go all the way till the end. And you see number 4. Now we have 5 factorial. Then we get 120, just like this. How about the second one? Second one is AP4. How are we going to go for AP4? Similarly, we just first press 8, and then press math, go all the way to the probability, right over here, and you'll see MPR. That's what AP4 is. First number is N, the second number is R. So in this case, we're going to go for number 2, and AP4 becomes our answer, and that was equal to 1680. How about the third one? 12C7. Alright, 12C7 is a similar way as before. 12 math and all the way to the probability. And NCR, that's basically what we have to use for 12C7, which is equal to number 3. And press 7. There it goes. So these are the answers for the first 3. 1680 and 792. How about the last one? In fact, this is equal to exactly same. This is called binomial coefficient, but same as 15C10. Now we can calculate this one by using the calculator, just like earlier. So type in 15, go to math, and go to probability, and type in 3. So 15C10. And if you press enter, then we'll get 3003. That becomes our answer. Alright, let us move on to the next question. How many numbers of the different arrangements are possible? So here, the number of arrangement can be calculated by n factorial, where n is the total number of letters, divide by r1 factorial, whatever number that's repeating, and then r2 factorial, whatever number of another letter that's repeating, so forth and so on. Now, then how many letters do we have? 1, 2, 3, 4, 5, 6. So this has to start with 6 factorial. Now, how many letters repeats? We have D repeats 2 times, so we're going to divide by 2 factorial. And I also repeats 2 times, so 2 factorial. And the other one doesn't repeat, so we just don't have to write it, or you can write down as 1 factorial, which is equal to 1. Then here, this becomes 6 times 5, or we can use the calculator. Why don't we try to do that one more time, just to practice. 6 factorial. That means what are we going to do? 6 math all the way, and then number 4 over there, get you 6 factorial, which is 720. But we're going to divide that by parentheses 2 factorial, number 4, and another 2 factorial. Number 4 once again, and 180 becomes our answer. Alright, let's move on to the next question. Determine the number of different arrangements. Finishing order of 7 runners in a race. That means we have to rank them number 1 through 7. Then how many possibilities do we have as a first place? Any one of the 7. And second place will be 6 possible choices because 1 was already used. And then 5, 4, 3, 2, 1 for the same argument. If you multiply all of them out, I'll be just going for 7 factorial, number 4. Alright, the answer becomes 5040. Alright, let's look at number 6. How many combinations of 4 numbers are possible here? A buyer of the lottery ticket chooses 4 numbers from 1 through 32. So in this case, the order doesn't matter. So therefore, what we end up getting is this. Out of 32, how many ways can we choose 4 letters? That's basically what we end up getting. Then here we have 32. Since the order doesn't matter, here number 3, combination. And then we are choosing 4 numbers. So there it goes. Our answer is 35960. What is the probability of choosing all 4 winning numbers? Now, all 4 winning numbers. How many winning numbers do we have? There is only 1. So therefore, our answer will be probability will be 1 out of this many possibilities. 35961 or 60. All right, let us move on. Number 9. 3 cards are drawn from the standard deck of 52 cards. Without replacement, what is the probability that all 3 cards are king? What is the probability of getting a king first? Yes, there are 4 kings out of 52 cards. How about second time? Because I used 1 card, there are only now 3 kings possible. But out of 52, now we only have 51 choices because 1 card was drawn. Now, next one also has to be a king. Then how many kings do we have? We only have 2 choices out of 50. So that's basically what we have. Then once you calculate this one, let's try to do that. 4 divided by 52 times 3 divided by 51 times 2 divided by 50. Alright, and that's what we end up getting if you have to convert that into fraction. Alright, that becomes 1 out of 5525. That becomes our answer. Alright, the letters of the word seed, SEED, arranged at random, right? What is the probability that the arrangement begin and ends with E? Now, so the fact that means the probability has to be, the denominator has to be all possible choices, which means how many ways can we arrange these? It will be 4 factorial because we have 4 letters divided by 2 factorial because we have two letters that are the same. Now, but the thing is, in this case, we want to have begin and end ending with E. That means, let's see, how many possibilities do we have in the first slot? Any one of those two numbers any one of those two E's would be fine. Now, but in fact, one way for us to look at it into is this. This one has to be E, and the other one also has to be E. Those two are fixed. Only things that which we can move is S and D can be either here as SD or DS. We only have 2 possibilities. So our answer is 2 over 4 factorial divided by 2 factorial. Now, then what is this equal to? 4 factorial will in fact becomes 24 over 2, which becomes 2 over 12, which is equal to 1/6. And that becomes your answer. Number 7 here, let's look at it. The probability that our team will win a basketball game is 2/3. What is the probability that they will win exactly 5 out of next 7 games? So that means we can have a formula for this one. In other words, basically, if I have to explain the formula, we're going to have out of 7, we just have to win 5 times. Now, how many arrangements can we have? We have no idea, so we just use the 7C5 to talk about the arrangement. How many ways can we can win 5 games? But the thing is, the fact that we are winning, that means we have to have 2/3 we gotta have 2/3 5 times. We have to win 5 times. That means we are losing 1/3 only 2 times. That becomes our answer. Now, to calculate this one, we're gonna have 7, 3, 7C, 5. Now, I'm taking care of the first one. 21, multiply that by parentheses 2/3 to the 5th power. And we gotta have 1 divided by 3 square. And then what is we wanna put this one into 4 decimal places. So we're looking up here. That means 7 has to influence 2. So we end up getting 0.3073 becomes our answer. And that's it. I'll see you later. Bye bye.